Good morning, friends. Our today's topic is intensity of pressure or simply pressure. So, basically, intensity of pressure or simply pressure is denoted by P, and that formulates like pressure force divided by area. We are writing it as like this: force divided by area. Now this force is nothing but the pressure force, and this is area. The unit of this intensity of pressure or simply the pressure, so unit of force is Newton, unit of area is meter square, so Newton per meter square. This we may also call it as the Pascal, or simply 1 Pascal. So before starting this intensity of pressure or the pressure, we should know the basic difference between stress and pressure. So stress is denoted by sigma, and that is also having the same formula F divided by A, and having the same unit Newton per meter square. But pressure we are using in case of fluids, and stress is used in case of rigid bodies. So that is the basic difference. This is used in rigid bodies, and this is used in fluids. So this is the basic difference. If we see what is stress conceptually, suppose take any specimen, or this is the any rectangular bar that is applied by the tensile force from both the sides, means the bar, we are pulling the bar in opposite direction, so these forces are tensile force because they are in opposite direction. If they are in same direction, we are seeing it as compressive force. If we see the internal particles, what they are doing, suppose we are talking about this force that is applied on this much area A, so the particle here they got stressed, means sigma is equal to F divided by on that area A. So at this point the stress occur, that is internally. But usually we are saying stress is nothing but this force applied on this much of area. So that is the basic concept. Here the particles are resisting this force on this much of area A. So resistance provided by the particle is nothing but the stress, and both the terms are similar, F divided by, but this that is used in case of fluid and this one is used in case of rigid balls. The next we'll see briefly what is pressure intensity. Suppose we'll take an example. Suppose there is a container and in that container water is there. Now if I want the weight of water, will we able to calculate it? Yes. We fix the geometry of this container. Suppose that container is in a circular shape, or we may say the cylindrical shape. So we can able to calculate the weight. So actually what is pressure? P is equal to weight of water divided by area. Now here we are saying it as pressure force, and here I have written it as weight of water. See, weight is also a type of force. So if we are going to calculate the pressure at this point, at the pressure at bottom bottom of the container, that means weight of water above that bottom. So this much is the weight of water. So for that case we need height h, height of water, that is h. How we are going to calculate the weight? So in a previous lecture we have seen how we are going to calculate the weight of any material. Now this one is the fluid. So there is a formula, weight W is equal to, sorry, there is one formula, that is specific weight is equal to, that is denoted by small w, is equal to weight means capital W divided by volume. Specific weight is equal to weight divided by volume. So weight is equal to W is equal to small w multiplied by volume. Small w we may also write it as density, that is rho multiplied by g multiplied by volume. So this is the formula to calculate the weight. Now weight of water is what? Rho multiplied by g multiplied by volume divided by the area A. So this density is nothing but the density of water. So we can say that rho multiplied by g multiplied by volume. How to calculate the volume of water that is in container? So that is area. Now we have taken the container, cylindrical container. So volume we can calculate it, that is area A multiplied by height divided by area A. So we are saying that this area and this area get cancelled. So we got the formula P is equal to rho G into H. This is the pressure intensity or pressure, simply the pressure. So from this formula we are saying that pressure intensity directly depends on the height of water H. If height of water increases, pressure intensity increases, and this doesn't depends on area. We may also conclude from this. So if we see by an example, we take a simple example of pressure intensity, how it varies. Suppose this is water table, or we may say water surface, and this one is the dam, any dam suppose, and this is the ground level, bottom surface, hard strata. This we call it as upstream side, where the water is stored, and on the other side we are saying it as downstream side, where the tailwater is there. So how it varies, or we may say how the pressure intensity varies from water surface to the bottom level. So if we see the diagram that goes like this, if we take the cross section, so I'm going to draw the diagram here only. So simply this is the water surface and this one is the bottom. So pressure intensity increases as we go down. So here the pressure intensity P is equal to W into H, and here the pressure intensity is 0. So at the surface the pressure intensity is 0, and at the bottom P is equal to W multiplied by H. So it varies linearly because P is directly proportional to H. As we go down, pressure increases. This we may also write it as rho G is W multiplied by H. Here that W is rho G, so this we may also write here like this. So in this way we can see how the pressure varies. As we go down, pressure increases, and at the water surface pressure is, or intensity of pressure is 0.